In this video, you will learn about geometric sequences. A geometric sequence is a sequence that progresses with multiplication. The formula is a sub n equals a sub 1 times r raised to the power of n minus 1. A sub n is the term we're looking for. A sub 1 is the first term in the sequence. R is the common ratio. And n is the term we're looking for. Example number 1. What is the common ratio? 5, 15, 45, 135. So here we are looking for the common ratio. The idea of a geometric sequence is that it progresses with multiplication. So 5 times something will give me 15. That'll be times 3. 15 times something will give me 45. That's times 3. And 45 times something will give me 135. That's times 3. So the common ratio, which is r, equals 3. So in an arithmetic sequence, we had a variable of d for difference. In a geometric sequence, we have a variable r for ratio. Example number 2. What is the common ratio? I have 3, negative 3 over 2, 3 over 4, negative 3 over 8. So I know that I'm looking for the common ratio. So I'm going to start by making my whole number 3 into a fraction by writing it over 1. So in a geometric sequence, we are multiplying. So I need to find out what did I do to the 3 over 1 to get a negative 3 over 2. So I know I'm multiplying, so I'm going to place my dot for multiplication. So I'm going to start with my numerators. What did I do to the 3 to get a negative 3? I multiplied by a negative 1. Now my denominators. What did I do to the 1 to get a 2? I multiplied by 2. That means I multiplied by a negative 1 over 2. Now the next one. I'm going to start with my numerators. What did I do to the negative 3 to get a 3? I multiplied by a negative 1. Now my denominators. What did I do to the 2 to get a 4? I multiplied by 2. So that means I multiplied by a negative 1 over 2. Now the last one. I'm going to start with my numerators. What did I do to the 3 to get a negative 3? I multiplied by a negative 1. What did I do to the 4 to get an 8? For my denominators, I multiplied by a 2. So that means I multiplied by a negative 1 over 2. That means that my common ratio, which is represented with r, is negative 1 over 2. Example number 3. Find the 10th term in the geometric sequence. I have 3, negative 3 over 2, 3 over 4, negative 3 over 8. So we're looking for the 10th term. As you recall, these are the same numbers from the previous problem. So we already found the common ratio. So I'm going to write that to the side. So r equals negative 1 over 2. Now to find the 10th term in the geometric sequence, we need a special formula. That formula is a sub n equals a sub 1 times r raised to the power of n minus 1. Now I'm going to use my numbers and plug them into the formula. So a sub n is the term we're looking for. We are looking for the 10th term. So that'll be a sub 10. A sub 1 is the first term. We know the first term to be 3. We're going to multiply by our ratio, which is negative 1/2. And then n is the number of terms. We know there are 10 terms, minus 1. Now I'm going to bring down a sub 10 equals 3, bring down negative 1/2, and then 10 minus 1 is 9. Now I'm going to bring down a sub 10 equals, bring down 3. Now I'm going to take negative 1/2 and multiply it by negative 1/2, multiply by negative 1/2. I'm going to do that 9 times until I get a negative 1 over 512. Now I'm going to bring down a sub 10 equals, now 3 times negative 1 over 512 will give me a negative 3 over 512. So that means that the 10th term in this geometric sequence is negative 3 over 512. Example number 4. Find the 15th term of the geometric sequence. The first term is negative 4 and the ratio is negative 2. So we are looking for the 15th term. So we need to use the formula a sub n equals a sub 1 times r raised to the power of n minus 1. I'm going to use my numbers and plug them into the formula. A sub n is the number we're looking for. We are looking for the 15th term. That'll be a sub 15 equals a sub 1 is the first term, which is negative 4, times r, which is the ratio, that's negative 2, and then n is the number of terms. We know there are 15 terms, minus 1. I'm going to bring down a sub 15 equals negative 4 times negative 2, and then 15 minus 1 is 14. I'm going to bring down a sub 15 equals negative 4 times, and then negative 2 raised to the power of 14 means it's negative 2 times negative 2 times negative 2, 14 times. That's going to give me 16,384. Now I'm going to bring down a sub 15 equals negative 4 times 16,384 is going to give me negative 65,536. So the 15th term of the geometric sequence is negative 65,536. Example number 5. Write the general formula for the geometric sequence. The first term equals negative 4, and the ratio equals negative 2. So we are looking for the general formula. The general formula means we don't know what n is. We can find the 10th term or the 20th term. So we're going to start off by writing the basic formula, which is a sub n equals a sub 1 times r raised to the power of n minus 1. Since we don't know what n is, we're going to leave it as is, so it'll be a sub n. A sub 1 is the first term, which is negative 4, times r, which is the ratio, and that's negative 2, raised to the power of n minus 1. We don't know what n is, so we're going to leave it as is. So this formula will work for the sequence to give you any term you want. So if you want the 13th term for the sequence, plug 13 in for n. So the general formula for this geometric sequence is a sub n equals negative 4 times negative 2 raised to the power of n minus 1. And that's how you solve for geometric sequences.